Hello everyone, my name is Ali, the Bazooka Prophet, and today we're going to be working on a very interesting video in the field of physical chemistry, talking about what we call the stoichiometry of solution. And remember, we've established the fact that concentration is one of the major units used under stoichiometry of solution. And we said that we have percent by mass, we have molarity, we have molality, and now what we call normality. And this normality has been a problem to many students. A lot of people have complained that normality is this, is that, but I'll prove to you that it is not difficult at all. It is very easy. Just follow how I'm going to do it, and also the examples that will be solved under this topic, normality. Now, we move. Now, we should understand that normality is the number of equivalent of solute per the volume of the solution in liters, as you can see right here on the board. And that each of these terms can be broken down into fragments. Knowing fully well that to get the number of equivalence, it is equal to the mass of the substance over the equivalent weight. Now, before I make progress, we should understand that there's a relationship between molarity and normality, in the sense that normality is equal to the number of equivalents multiplied by the molarity. It will give us our what now? Our normality. Now we move to talk about what we call equivalent weight. Now, what's equivalent weight? Equivalent weight is the molar mass or formula mass or the molecular mass divided by your reacting units. Now, these reacting units can be a problem to some students not knowing how to get your reacting unit, because if your reacting unit is not properly obtained, you can have an incorrect answers while trying to get for your normality, because in getting for your normality you must get your number of equivalents and your equivalent weight. Now, what is the reacting unit in this case? Simple. Now, the reacting units, as I define it on the board, is the number of hydrogen ion or hydroxide ion in the case of acids or bases. But when it comes to that of the redox, which is reduction or oxidation processes, it takes another route entirely. Now, in terms of redox, we should understand that reacting units is the change in oxidation state per mole of the redox substances depending on the reaction medium. Depending on the reaction medium. The reason is that if the inability to get your reacting unit from your redox will pose as a big threat and a problem in getting your answers. Now, in this video, I will be taking some questions and solving it. Now, the first question says, calculate the equivalent weights. Look at that. Calculate the equivalent weights of the following substances. A, we're given for that of ammonia. B, oxalic acid. C, potassium permanganate in acidic medium, as we said earlier under reacting units. Then D, potassium permanganate in a basic medium. Now let us see how we can address it. Now we pick for the first one, A. Now remember that we have said that equivalent weight is defined as the molar mass over the reacting unit. Now, the molar mass of as equivalent weight. Now, equivalent weight. So, for A, the molar mass of ammonia is 17. Is 17. 17. Which is nitrogen is 14, Hydrogen is 1 times 3, which is 3 plus 14, plus 14, give me 17. Now, divided by, now remember that ammonia is a base. Is a base, which is also called, which is ammonia in an aqueous medium is equal to NH4OH. Telling you that the number of, when this one now should dissociate, the number of hydroxide ion here will be 1, which is 1. So you're having NH4 plus and OH minus, so it is just 1 more here. So it means it is 1. So the reacting unit here is 1. So it will be 17 divided by 1 will give me 17. Equivalent what? Weight. So it will be 17 equivalent what? Weight. So we move to the next example. All right. So the next question says, calculate the equivalent weight of oxalic acid, which is very, very simple. So we move down here for B, which is for that of oxalic acid. We should understand that oxalic acid is H2C2O4. And if that is done, knowing fully well that equivalent weight is equal to the molar mass over the reacting unit. And the molar mass of oxalic acid, which is, okay, so let us do it. So that's 2 plus 24 plus 64 will give me 90. So here is 90 divided by, now observe, this is oxalic acid, which is H2C2O4. So the number of reacting units here is what now? Is 2, in the sense that what you are having here, this is the same thing. This is the structural form of oxalic acid, in which when it is being ionized, there will be, I'll be having something else. Another one again. So it means 2 hydrogen ions here are involved. So it will be 2 hydrogen ion, which is the reacting unit. So it means here becomes what now? 2. So 90 divided by 2. So 90 divided by 2 will give me 45 equivalent weight. So that is the final answer to this example 2. Now, in example 3, we'll take our time to illustrate it, which is for potassium permanganate. So move to the next example. All right. So the next question is the equivalent weight of potassium permanganate in acidic medium. So please understand, listen to how I'm going to explain this one for you, because this is a redox and a lot of students have been having issues with this particular area. Now listen. Now do not forget that we have said that equivalent weight is equal to, now let's move on, the molar mass of potassium permanganate is 158 in the sense that the relative atomic mass of potassium is 39, manganese is 55, oxygen is 16. So 16 times 4 will give me 64 plus 55 plus 39. Altogether will give me what? 158. Are you with me now? So we move here. So now is not the reacting unit. Now listen. For potassium permanganate in acidic medium, it will be MnO4 minus to Mn2 plus, in the sense that potassium permanganate in redox, the oxidation state will change, which is from +7. Remember, the state here is potassium permanganate. The state of manganese here is +7, while that of manganese here is what now? Is +2. So the change in permanganate to manganese 2 ion is +5, in the sense that 7 minus 2 will give me what now? 7 minus 2 will give me +5. So if I have +5 now, that will not be the answer yet, because that +5, remember we have said that reacting unit is the change in oxidation state per mole. So per mole here, the number of manganese, because I'm looking for this one here now, which is potassium permanganate, the number of mole of manganese here is 1. As you can see here, is 1. So it will be times 1, which will then give me 5. And even I was having something like, let's say CR207, and I'm looking for the oxidation state or change here. The number of mole of the chromium here will be times 2. But because this one is 1, it will be 5 times 1, which will give me 5. So here becomes 5. So when I divide it, I'll be having it to be 31.6 equivalent watt per weight. So that is the final answer to this. Please do not get it twisted. In terms of, so get for the molar mass, then get for the reacting unit. In the sense that the reacting unit for Redox is the change in oxidation. The change here is meaning from +7 to +2. The change is +5. Multiply it by the number, by the species, which is the substance that is being reduced, which is manganese here. And that one do you have here is 1. So times it by 1. That is how we got it. Now, lastly is, okay, let me do this one for a neutral medium. A neutral medium. Now, in the case of potassium permanganate in a neutral medium, it's also very simple. So that equivalent weight is equal to the molar mass again. This one is 158 divided by. Now we move. Potassium permanganate here. It's from manganese permanganate to MnO2. That is how it is. So that here is from +7 to +4. So first of all, the change here will give me what now? It will give me 3, which is 7 to 4. The difference here is what? Is 3. How many mole of manganese do I have here? Just 1. So times by 1. So here becomes what? 3. So 158 divided by 3 will give me 52.67 equivalent weight. That is the final answer to this what now? To this question. Now, this is just the part 1. In part 2, we'll now enter normality proper. For now, I remember humble self, Adrenaline, the Bazooka Prophet, your friend, your brother. For any question, you can swear, put it on the comment section, and as soon as I see them, I will relate to you and give you more info. Please do well to share this video, like and subscribe, and tell your friends. God bless you.